Now we will see the mathematical description of the digital control loop. So as you see, this is our plant, this is the whole circuits, this is the sampler, this is the computer, and this is the sampler. Means this is the controller, digital controller, this is the sampler, this is the whole circuit, and this is the plant. Okay, this is your error detector, this is your sensor. Initially we have taken a unity feedback. Now we are showing the actual sensor transfer function H of S. So it is in the S domain. As you can see, it is in the continuous domain, S domain. Whole circuit is converting the digital control signal into continuous time domain, and it is actually U of T. Okay, it is in the time domain, and this is also in the time domain, Y of T. Okay, output. So it is time domain, Laplace transform, transfer function. This is also transfer function, hold, because it is converting the digital to analog, and this is in the Z domain. Digital computer is in the Z domain, means you need to take the Z transform of this. And this is ET, this is EK, this is the sampler. Now what is sampler, right? This will be in your mind. What is the sampler actually mean? Actually the continuous signal will be discretized. The switch will be on and off after certain amount of time, which is called the sampling period. So in every sampling period it will touch, or it is on, so signal will be available here. So the total error signal it is not taking, it is taking at every sample instant. That sample instant will be t equal to 0, t equal to 1, t equal to 2, t equal to 3, like this. So that will be mentioned by this k. K will start from 0 to n. Okay, k equal to 0, it will touch, one signal will come, again disconnect. K equal to 1, again it will touch. In this way it will do the sampling. Okay, so this is the structure. Now we will see the mathematical representation or description of the digital control system block. Now let us define the digital computer, that is the, or the digital controller, you can consider this. It is a controller, digital controller. Okay, what is this? D of Z equal to, we will consider that it is M of Z divided by E of Z. So this is M of Z, this is E of Z. Means E of K should be considered as in the Z domain, and M of K should be converted to Z domain. Then it is a transfer function. It is also a transfer function. G of S is output by input, Y of S divided by U of S. So it is also a transfer function, D of Z. It is M of Z divided by E of Z. It is in the Z domain, it is in the Laplace domain. Okay, now you see dz, we have written mz by dz. Now we will try to find out what is mz, what is dz. Okay, now I am writing the expression for m of z. What is m of z? M of z will be z transform of m of kt. Okay, t as I have told, sampling period, and k is starting from 0, 1, 2, 3. So this m of k, as it is on and off, accordingly this m of k also will change, m of 0, m of 1, m of 2, m of 3, like this. So this signal m of kt, discrete signal, will take the z transform, we will get the z domain output, m of z. Now we will find out the E of z. So what is E of z? E of z equal to what? Z transform of E of kt, z transform of E of kt, E of k, E of kt, z. Error signal, E stands for this, so this error signal will take the z transform. Next is this, what is this? Y of z. Y of z is this multiplied by this multiplied by this, E of z. So E of z is acting as a input, Y of z is the output, but it is in the Laplacian domain, so whatever there, g of h of s into g of s, we will take the z transform. This term multiplied with this dz multiplied with the input, this is the input, equal to your output. Okay, next is Ez. What is Ez? Now what is Ez? We have written this yz equal to this multiplication into Ez. Now what is Ez? Ez equal to r of t minus b of t. Okay, so but it is in the z domain, so it must be r of z minus b of z, r of z minus b of z. Okay, now what is b of z? What is this b of z? So E of z is applied here, multiplied by whole terms, so b of z equal to this input E of z multiplied by total whole terms. Okay, so what is this? This E of z is the input, acting as the input, and b of z is the output. So b of z equal to E of z into whole terms. What are the whole terms? This d of z into z transform of this g h of s and g of s and h of s. So we have written g h0 of s, g of s into h of s, z transform multiplied by d of z into input E of z. So you can write this E of z here or here. Okay, so this is your P of z. Next we are writing what is R of z. What is R of z? From this equation, R of z equal to E of z plus B of z. So R of z equal to E of z plus Ez plus Bz. So Bz we have already defined here, so this whole term will come here, Ez plus this. You see, R of z equal to Ez plus Bz, so we have written R of z equal to Ez plus this